Okay, hello guys, my name is Desmond and I welcome you to my lesson for today where we'll be looking at Physical Sciences Paper 1, Vectors. So good people, I hope you did enjoy your mathematics lesson where you were with Mr. Sibanda looking at laws of exponents. So just in case if you're watching this lesson on one of our platforms, it could be on the website or YouTube channel, just make sure to subscribe. And most importantly, in case if you've got any questions in relation to today's lesson, you can just comment in the comment description and I will surely attend to your questions. So guys, most importantly, what I'm going to be doing is to go through the given statement, take you through the given diagram, and again, most importantly, go through the question. So guys, a day without learning something new, it's a day wasted. So just make sure that by the end of each and every lesson that I conduct, you learn something new. Okay, so before I read through the given statement, are we all good, guys?
Yes, sir.
Yes, sir.
Okay, 100%. So, this is what we're given, guys. Question number 2, it's exactly what we'll be looking at. And most importantly, guys, make sure that you start each question on a new page. Very, very much important because it makes your work very neat. So the statement reads as follows. 3 forces P, Q, and R of magnitude 500 Newton, 200 Newton, and 300 Newton respectively act on point O in the directions shown in the diagram below. The forces are not drawn to scale. Very, very much important, ladies and gentlemen, that at all times, when you read through the given statement, you take note of the important information. So what I'm noticing there is that we are talking about 3 forces. Very, very much importantly. So that means it is 3 forces that I must be aware of. And those forces are given names. The first force is called P, second force Q, and the third force called R. So that means this order, it follows the order of these letters, which means 500 is for P, 200 is for Q, 300 is for R. Most importantly, guys, at all times, remember that in physical sciences, we've got what we call vectors and again, what we call scalars. What are these things, guys? These are what we call the physics quantities. So you need to be aware that in physical sciences, we've got 2 types of quantities. The first quantity, we call it vector quantity. Second quantity, we call it scalar quantity. It doesn't matter whether you regard the first one being scalar or vector, but you just need to be aware that a vector quantity has got both magnitude and direction. For example, it could be force, could be momentum, could be a velocity, displacement, and whatever. Those are what we call the vector quantities. Scalar quantity, something like time, mass, it doesn't have direction. It's only the magnitude or the size that it has. Let's see. So they are saying all these three forces respectively act on point O in the diagram, in the directions shown in the diagram below. And most importantly, the forces are not drawn to scale. So don't worry that much about that statement. You might need to refer to it. In some instances, you might not need to refer to it. So sometimes when they draw this type of diagrams, you will notice that the diagram with a longer arrow there, or with that long line, is the one with a bigger force, and then that one is a bit longer, it's 300. You'll find that maybe it's a bit longer than this one with 200 newtons. And again, they are simply saying this angle, it doesn't necessarily mean that when you use a protractor to measure that angle, it will be 100% 30 degrees. So that is what that statement means, to say the forces are not drawn to scale. So that means also, in my case, you can see this is just a hand-drawn diagram. It's not drawn to scale. So quickly, let me take you through something very, very much important, ladies and gentlemen. And I think this might also be useful when you do geography or geography. Right. So now we are having what we call compass. I'm not sure if you guys call it compass or compass, but whatever that you call it, you know very well that from primary you've got the north, and again you've got east, and you've got south, and again you've got what we call a west. Very, very much important, ladies. So quickly, I need to teach you guys how to determine directions of all the cardinal points using compass. So let's see, guys. You obviously going to have a line between that and that, and again between that and that, and again you are still going to have another line over there. So these lines in between, obviously the vertical line is more like your y-axis and the horizontal line is more like your x-axis. So if you want to easily label this, I think we call them 16 cardinal points or something like that. I'll just make sure to confirm that before I take you through a map work. So remember, guys, this line is just between north and east, so we call it NE. Why NE? Because it's between north and east. So this one, remember, we start with the vertical line, so it's between south and east, you call it southeast. This one is between south and west, you call it southwest. This one, make reference to the vertical line, so you start with the vertical line followed by the horizontal line. And again, you might be having some lines in between where you can use those to also give directions. So you need to be able to understand this thing, guys, so that whether in physical sciences or in this chapter, you'll be able to give directions. So you do the same, guys. This line is between north and north east. So you just say it's north, east. Let's see. What about this one? This one is also between northeast and east. So you can call it north, east, east. I think I'm right with what I'm doing over there. I'll just make sure to quickly confirm in case if it's east, northeast. So you just do the same line. Guys, this line is between that and that. So I think you can call it SE because of it's between SE and also that E over there. You do the same for all of these lines. So I just wanted you guys to be aware that when we give directions, for example, if you've got a force in that direction originating from the origin there, in terms of the direction, you can say it's north east. Maybe if it's in that direction, you can maybe say it's between north and northeast. It is therefore north, west. So in case if I've said east, but it's in this side of north west. And again, that line is between northwest and west. So you just combine those letters. I hope I'm correct with what I'm doing over there, guys. I'll just double check. I wasn't actually planning to show you this thing, but I think it is very much important that when we give directions to the forces, you know exactly where those directions are coming from. So let's see again. This one is between south and southeast. So it's going to be south, then southeast. This one between south and southwest. You just connect the width. And then this one, let's see, it's between south, west, and again west. So I think you can call it southwest, west. It seems like we have completed everything. Okay, then it's fine. Ladies and gentlemen, based on what I've said, let's try to estimate the directions of these forces acting. Let's see, forces respectively act on point O. So we've got 1, 2, 3 forces respectively which act on point O, which is that point over there. So I'm not sure, guys, if there's someone who can guess the direction for point P. In which direction is that force P? Remember, guys, don't give an answer. Just mention your name and I will recognize you, honorable member.
LB, sir.
LB, go for it.
So is it northeast for P?
Northeast for P. Let's check northeast for P. Northeast, acceptable, LB. So we can just say force P, it's actually currently in the northeast direction. Anyone to guess for force R? Shreyas, go for it.
Southwest.
Southwest, let's check. Southwest, of course, is also in that direction. Also southwest, it's acceptable. So let's say this one, it's southwest. Good people, anyone to just indicate for Q there. Remember, just mention your name and you will be recognized, honorable member.
Sir.
Remember, guys, I'm not sure if it's a question or it's an attempt to give the direction, but I heard Lerato mentioning her name. Lerato, go for it.
So the directions for Q is north, east, east.
Lerato, you're saying the direction for force Q is what?
It's north, east, east.
North, east, east. North, east, east. Yes, it seems to be north, east, east. Guys, just before we make a conclusion, did I write this correctly? Is this the correct 16 cardinal points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. Anyone to confirm for me? Those of you who are doing geography, did I write it correctly there?
Sir, you did.
Okay, 100%. So I suppose those of you guys who have been wondering how to write these directions, just remember you start with the vertical and the horizontal one, then you do those. From there, you just say this
Sir.
line is actually between north and east. Someone has got a question?
It's not northeast east.
Wait, where are we, LB? What are we talking about?
I get you asked if the compass is correct. Just some minor mistakes, but then yeah, same thing
Oh,
though.
so we are now on campus. You're saying is it incorrect? Did I write it incorrectly?
Okay, example, the northeast east that you wrote there,
Yes.
it's east northeast.
East, north, east. Okay. So I think I understand exactly where you are coming from. So let's see. It's more like also this one. It is therefore going to be east, south, east. Is that correct?
Yes.
Okay. So, ladies and gentlemen, it's more like from what LB is saying there, she's actually saying this line is between two lines and we start with the main line. For example, between north and northeast, which one is the main line between these two? Obviously, we started with that line for north, which makes it what? I think this one it might be correct as north east. Just confirm for me there. And then
Yeah, it's
this dotted
correct.
line, can you see, it's between south and southeast. So you ask yourself this question, between this line of south and this one of southeast, which one is the main line, or which one did you draw first? We obviously drew that one first. So you start with south and then you can secondly write southeast. Let's quickly check that one. We're going to say between these two lines, which one is the main one? The main one is the one that you drew first, is that one. So it's actually south. Then you can connect it with southwest. Let's see that one. It's between that line and this line. So between these two lines, which one is the main one? You might find that this is the main one. Possibly this could be west, southwest. Also confirm that one. So let's see. This line is between those two lines. Which one is the main one? Still that one, because you drew it first. Therefore, you might need to have west and then you join it with northwest. Let's see on this one. Also on that one, it could be between these two lines. This is the main. Then you might be having north. Then you join it with northwest. I think
Yes, it's
now
correct now.
it's 100. So all of you guys, before I proceed, did you now understand or do you now understand how to complete that compass that we call 16 cardinal points? Are you all happy there? Is there someone who's been left behind? Guys, are we all on the same page on that one?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, 100%. So let's see. Let's just maybe, I'm not sure. This one, it's east, northeast. Okay, let's write it as east, northeast. Let's see. I think that's what we said. East, northeast. Okay, so remember, guys, it is very, very much important that we try to give directions to these forces, because we know very well that a force is a vector quantity, which means it has got both the direction and the magnitude. So now we have the magnitude of force P being 500 in the northeast direction, and then we've got the Q force, which has got that magnitude in that direction. We've got this one and that. So let's try to visualize what's going on over there, ladies and gentlemen. Let's see. Let's say, for example, we've got this container hanging somewhere in the middle of the air. This is just a container, guys, and this container is full of gold. Very, very much important, guys. So because we know there's actually a gold in this container, we now have people trying to pull this gold in their directions. So let's see. We've got the first one trying to pull in that direction, and this guy has got very big muscles. Let's say this is who is that? Let's see. We don't have someone with a name that starts with P, but let's say this is Philip. Okay, Philip is so powerful that he's got a force of 500 Newton, and he's pulling this gold in that direction, ladies and gentlemen. So let's see. We've got Queen with smallanyana power there. She's pulling it in that direction at 200 Newton. Okay, let's see. We've got another. Remember, guys, this is a container full of gold. So everyone is trying to pull in a certain direction. Why are they pulling? It's because they want to pull it towards themselves. So let's see, where is Rosina in this group? There's no Rosina. Okay, so there we've got Rosina with some power nyana there, which is 300 newtons. So ladies and gentlemen, because we notice that Philip is pulling in that direction, if we want to know exactly in which direction, we need to therefore make reference to the angle. So let's say maybe this is the horizontal x-axis and this is the vertical y-axis. So to know exactly in which direction, we can try to measure the angle formed relative to either that axis or that axis over there. So you know how a protractor looks like, ladies and gentlemen. I think a protractor, it's something like that, and it has some angles there. So you take a protractor and then you put it in that direction. So you have that, and then you take this protractor and then you put it like that, and you try to read the angle formed as a result of Q. So that angle that you're going to get over there, you will find that it is that angle there being 30 degrees. So now we know that, okay, Queen is actually pulling in that direction at 200 Newton, and the angle formed is actually 30 degrees. You do the same measurement for our friend there, Philip. So you can see Philip is actually pulling so hard at 500 Newtons, and the angle formed is actually, what is it? Not 60, but let me just quickly correct that one. 60 is on the other side. So the angle formed there from here to there, it is actually 80, even though the angle that they are showing is this one of 10 degrees. So that is how examiner tries to trick you. So it's more like this angle formed when you measure it from the protractor and you go like zzz up to there, you'll find that it's actually 80 degrees. But examiner tries to be tricky. It doesn't give you angle from the horizontal axis up to there, but it gives you that angle between the vertical axis and that one. So he gives you that angle being 10 degrees. Why do I know that this one is 80? It's because you know that from this line, when you rotate up to that line, you have 90 degrees. So if you know you've got 10 there, that means the remaining is 90 minus that 10, it's 80. So it doesn't matter whether you consider or you take the 10-degree angle or the 80-degree angle. You will understand better there. So now, if you take protractor, you now rotate it such that you put it at that angle. You put it at that angle, and then you put it there to measure this angle. You'll find that when you measure that angle, it's probably 60 degrees over there. So that means Rosina, relative to that horizontal axis, is pulling in that direction at an angle of 60 degrees. So remember, guys, direction. Let me quickly check the other marker. I want us to discuss something very, very much important, ladies and gentlemen, in terms of the direction. So that means in physical sciences, directions can be represented in many ways. The first way, it can be represented in a form of an angle. So we obviously know that an angle can be anything from 0 degrees up to 360 degrees. And again, an angle, the direction, can be represented as upwards or downwards. Very, very much importantly. Again, it can be regarded as to the right or to the left. Do we have another possible way in which we can represent the direction in physical sciences, guys? Is there someone who can remember another way of representing direction in physical sciences? Guys, or do you also know of this three?
Yes, sir.
Okay, so for now, let's just make an assumption that directions can possibly be indicated as an angle, up or down, right or left. Whatever that we discover as we go along with our physics lessons, let's make sure to add it on the list. Very, very much more. So, good people, here comes a question.
Sir, how about northwest or south? Something like that. Isn't that the direction?
Yes, 100%. So, in terms of the directions, we can also represent it as north, east, south. Let's say, or west. And most importantly, you can still have those, let's say, 16 cardinal points. So that also includes your north, northeast, south, southwest, and whatever. So that's another way of representing directions in physical sciences. So thanks very much, Madam Speaker. So let's just make sure that whatever that we can think of, we add it on the list, just so that when you're dealing with physical sciences, the moment they mention northeast, south, or west, or whatever, quickly you remember that you might be dealing with a vector quantity. So I was about to ask a question of which I'm expecting you guys to just mention your name, and I will recognize you, honorable member. So here comes a question. We have got Philly pulling in that direction. We still have Madam Queen pulling in that direction. So here's another one. Ross, she's pulling in that direction. Generally, in which direction do you think this box full of gold is going to go?
Sir LB.
Noted, LB. Wait. I know I've spoken to you, LB. I just want to confirm before I give you a go ahead. Is there someone, a new voice also, who wants to give it a try? Because with me asking these questions, it helps to understand if you do understand the questions, and again, if we are still on the same page. Guys, did you understand the question? And again, is there someone else again who wants to give it a guess? Okay, no one. LB, give it a try. Give it a try. Let's see.
Wait, wait, can you please repeat your question one more time?
Okay, so I wanted to know in terms of generally, by just looking at the directions in which these forces are being applied, do you think Bra Philip and Sister Queen there, will they manage to pull that container full of gold in their direction as opposed to Rosina pulling in that direction? So I'm just asking generally, in which direction will that container full of gold go, and why the direction that you're choosing?
So in the direction of Philip, because Philip has more force compared to others.
100%. So LB, exactly what you're saying, it's exactly what I expected a response. So, ladies and gentlemen, in short, this container, it is actually going to move generally in that direction. And the reason to that is because you can see you've got Bra Philip, you've got Sister Queen, both of them pulling in the first quadrant direction. And you only have Mros pulling alone at a force of 300 in the third quadrant direction. So, does it make sense to everyone before we start with our questions? Are we all on the same page there?
Yes, sir.
Okay, 100%. So now I'm just going to remove all of this, and then from there, we try have a look at the questions. So remember, guys, just in case if you are not following, just make sure to comment, because with me explaining and also asking the questions of which you are not able to attempt, I end up not being sure if we are all on the same page. But just make sure that in case if you need clarity on something, you indicate so that we move together. Okay, so let's see, we still have that. What is the first question saying? Is there someone who can be able to read the first question there? Anyone?
Yeah, so let me read it. It says refer to the information in the diagram above and give a reason why forces P, Q, and R are classified as vectors.
Okay, so always, guys, especially in physical sciences, life sciences, and geography, not that much in mathematics, but you need to identify the cream of the question. What is the cream of the question? The cream of the question is that word or those words, when removed from the question, the whole of the question will remain senseless. So I've got that question now, and this question is allocated 2 marks. So it says, as LB has read over there, which is 2.1, refer to the information in the diagram above. So it's an instruction to say refer to this diagram given above, and give a reason why forces P, Q, and R are classified as vectors. So already it seems like the word vectors is the cream of the question. Why? Because, Molefe, if you remove that word vectors, you remain with refer to the diagram refer to the information in the diagram above, which is that, and give a reason why forces P, Q, and R are classified as. That's if you remove that last word. So with just that, you won't be able to answer the question because it's senseless. It doesn't make a complete sense. So you needed that word being a vectors. Yes, it's vectors. You needed that word in order to be able to answer the question. So now that we've identified the cream of the question, which is vectors, what is it that you know about vectors, ladies and gentlemen? So I'm just guiding you in terms of how to approach physics questions so that even if you get it wrong, don't talk about beggars there. Don't talk about nuggets there. Do not talk about oros over there, ladies and gentlemen. Just talk something relevant or closer to what you know about vectors. So, Tebas, unmute your mic. In which grade are you, Tebas?
Grade 12.
You are in grade 12. Is there something that you remember about vectors?
Yes,
What is it that you remember
it has
about
something.
vectors?
It's something to do with magnitude and direction.
100%. You can mute your mic. Onkamogetse, in which grade are you, Madam Speaker?
Grade 12, sir.
Grade 12. So, can you now see that because we have identified the cream of the question, in answering this question, we just need to talk something that is to do with magnitude and direction. Does it make sense to everyone there?
Yes, sir.
Yes.
Yes, sir.
So, LB, I want to show you that answers in physical sciences, they don't necessarily need to be exactly the same. I can explain that using my Limpopian 2 minutes English. But one thing for sure, it will be given full marks. So, what can you say, LB, in answering that question by making use of what honorable members have said over there?
So do we say wait, P, Q, and R are classified as vectors because they have direction and magnitude? And do we have to mention the directions for each?
Okay, so ladies and gentlemen, with what LB has just said, she will be given 2 marks. Why? Because she has mentioned what is it? Magnitude and direction. Whatever that she's going to say in terms of specifying the exact direction, it will be just her not running out of English bundles. But for someone like me who comes from Limpopo, I'll just end it there to say because of that and that. So the moment you go further, and just make sure that if you go further, you get it correct because that's how you win the marker's heart. We know that, okay, this Madam Speaker knows exactly what she's talking about. She knows exactly what she's doing. Then even when I mark your paper at Marking Center, I'm going to pay full attention to everything to such an extent that I will also need to understand in case if you got something wrong. I'll try to understand how did you get it wrong. So LB, with what you've just said, it's 100% you are going to get full marks. Whatever that you'll be saying, it will be you providing additional information which will not be given extra additional marks. Chanel Malaj, did it make sense there? Let's see. Shreyas, did it make sense?
Yes, sir.
Okay, 100%. So now let's try to move to the next question and see if we can manage to win on this question. So I'll just read it. I've got the question. It says, determine the magnitude and direction of the resultant force either by calculation or by accurate construction and measurement. Okay, it ends there, and then they say use scale 10 millimeters. It's equals to 50 Newton. So what I'm going to be teaching you is to determine that by means of calculations, because it is the most reliable way of answering the question. But most importantly, guys, I need to ask you this question. What is the cream of the question? I'm not sure if there's someone who can go click on back and check that question paper, read through and mention your name in case if you want to try and tell us what could possibly be the cream of the question. Remember, guys, it's worth it to give me an incorrect answer because it's going to help me to explain even better. So just make sure that you don't worry that much about your answer being wrong or correct. So tell me, guys, determine the magnitude and direction of the resultant force either by calculation or by accurate construction and measurement. So my question is, what is the cream of the question?
Alisa.
Noted. LB, let me try to check if there's another one who wants to give it a try. Anyone else, guys?
Debat.
Tebazo, noted. Anyone else, guys? Okay. Tebazo, go for it.
I think is a resultant force.
Okay. LB, go for it.
So I think it's determine the magnitude and direction.
Okay. Thank you guys for those inputs. So, ladies and gentlemen, remember, when I say what is the cream of the question, always you should remember that the cream of the question, it's not limited to a less amount of words. So the whole sentence or the whole question could be the cream of the question. So you just need to make sure that what are those words when removed from the question, the whole of it will not make any sense. So in your own right, there's no mark to determine or to identify the cream of the question, but you just need to make sure that if you remove those words that you say they are the cream of the question, you won't be able to answer the question. And sometimes you might find that you've got more words which form part of the cream of the question. In my case, I would say both of what LB said and what Debatso said combined form the cream of the question. So LB said determine the magnitude and the direction So with that alone, LB, I can say it's part of the cream of the question. It's more like it's half of a cake. To complete it, we complete it with of the resultant force. So that means with the question saying determine the magnitude and direction of the resultant force, that is the cream of the question. So an instruction says either by calculation or by accurate construction. So that means in every question, guys, you can write it down. You must be having the cream of the question. And again, you might be having instruction. So we can see in this question, we do have the cream of the question, and again, we do have an instruction. Instruction is where they say by calculation or by accurate construction method. So what I said is that I'll show you the method whereby we perform some calculations over there. Before I start, guys, are we now on the same page?
Yes, sir.
Yes, sir.
Okay, 100%. So remember, guys, we've got the y, and again, we've got the x axis. So always when a force is being applied at an angle, in this case, let's maybe say that one of P is being applied at that angle. Just be aware that, okay, that angle formed there is that one of 10 degrees. Just know that because this force is being applied at an angle, that means that force of P, ladies and gentlemen, that force of P which is being applied in that direction, it actually has two components. What are those components? The vertical and the horizontal component. So the vertical component, we can just show it by making use of the broken lines over there. So let's call it force P, maybe say V for vertical. And again, we also have another force which we can call force horizontal. So these are the two components of the forces of that force P acting at that angle. So can you see, guys, the given angle is that angle over there, and that angle is 10 degrees. So what we need to do, guys, is to form a right angled triangle so that we can be able to determine this vector quantities using trig ratio. So normally in this chapter, ladies and gentlemen, you always try to find a right angled triangle. How do you know a right angled triangle? You know it has a 90-degree angle, and you can see that 90-degree angle is actually going to be formed there. So that means either you can form a right angled triangle or the 90-degree angle using the vertical or the horizontal, and you do that after you have identified the angle. So that means if that angle was there, which we know that it's 80 there, then you're going to do a dotted line and you form a 90-degree angle there. But in this case, it's given there. So let's try to do the same for the force being applied by Queen. Very, very much important, let's say. So we know that we have got that being the origin over there, and Queen is applying a force in that direction. And most importantly, they are saying at an angle of 30 degrees. 30 degrees to what? To the horizontal. So this is that angle formed, which is 30 degrees. So can you now see that we can only form a 90-degree angle there by looking at that horizontal x-axis and again relative to that angle being applied by Queen. So that means this is therefore the force vertical or the vertical component of that force, and this is the horizontal component of that force over there. And most importantly, guys, we also need to do the same for this force being applied in that direction by Morose. And the angle formed, they say, is 60 degrees. So you just do the same, guys. Let's maybe see if we can manage to do it over there. Let's see. We do have the origin there, and we've got that force being applied in that direction, and it's called force R. And most importantly, guys, can you see that angle is formed or is measured along that x-axis, and they say is 60 degrees. So can you see now that this is where you form your 90-degree angle over there? Then you know this side, it is your V vertical, and this one, it is your V horizontal. So that means every force, it doesn't matter if it's that direction, and let's say maybe you are given that angle there, let's say it's 45. What you need to know is that this is the force in that direction, which could be called D for Desmond. Then this force, because it is at an angle, it therefore has both the vertical and again the horizontal component. So that means we're going to have V vertical, and then force vertical and then force horizontal, and you have a 90-degree angle formed there. Why do you always need to have that 90-degree angle there, ladies and gentlemen? It's because you know you want to use the trig ratios being sine angle, cos angle, or tan angle, and you can only use these on a right angled triangle. Ladies and gentlemen, before I continue, is there someone who's got a question over there, or does it make sense to everyone?
Wait, what were you explaining there?
Which part, LB?
Where you were drawing the Q and the R separately.
The Q and the R separately. Which one? Which part, L? Because this one and that one, I have explained. I was explaining somewhere something somewhere there. I want to know, do you still want an explanation on these two, or which part?
Yeah, so can you please explain that again?
Okay, so remember, guys, we've got a Cartesian plane, and we have that force Q in that direction. So this is that force Q. So you just want to have the vertical, or let me say you want to have a force vertical and again force horizontal. So these are the two components of the force of Q. So Q is being applied in that direction at a certain angle, and that angle, they said, is what? This is that angle being 30 degrees. So let's try to form a right angled triangle. So you can see that you are therefore going to have your right angled triangle there. So it's more like you form a right angled triangle on that axis which was used to measure the angle. So can you see that 30 degrees, it was measured from the x-axis. So that is why you also have a 90-degree angle there at the x-axis, which means this side which is now the hypotenuse. This is the force of QLB. So because this is the hypotenuse, we know very well that when we have a right-angled triangle, we have the opposite, which is going to be V vertical in this case. And again, we have another force, which is a force horizontal. So that means when you have one force being the hypotenuse, this force, it has got two components, which is the vertical component and the horizontal component, just like we explained also with that one for P. But something interesting about P is that this force for P, you can see that the angle is actually measured about the y-axis being 10, about the y-axis. So that is why a 90 degree is formed there about that line. So that is why I was saying we have a 90 degrees angle based on the line that was used to measure that angle. So let's check again for a force of R, which is in that direction. So this is the force of R. So can you see they used this line of x-axis to measure the angle to be 60 degrees. Therefore, it means our 90-degree angle is going to be right along that line of the x-axis, which means this force is actually the hypotenuse force. Then this is going to be the force component of this side, and this one is going to be the force component horizontal. So that means always when you have a force which is at a certain angle, you will always have two components, being the other vertical force component and the horizontal force component. I'm not sure if it makes sense there, LB and everyone else.
Yes, sir.
Debatso onkamogetse le Shreya's Boipelo. Are we all on the same page there?
Sir.
Yes, sir.
Okay.
Yes,
Sir.
sir.
So let's try to quickly check if we can answer that question. So remember, guys, the question says determine the magnitude and the direction of the resultant force, either by calculation or whatever. So the resultant force, it's more like LB. We want to actually perform calculations to show in which direction, at what amount of force will this box of container move. So already we were able to notice that by just looking at those forces to say, because we have Bra Philip pulling that direction, we have Sister Queen in that direction, and this one with a lesser force. So generally, this box of gold, it will generally be in that direction in the first quadrant. We are just not sure exactly in which direction, and again at what amount of force. So just to make it easy for you guys to understand, if we had two forces, let's say we had force of 50 Newton upwards and we have force of 70 Newton upwards, and we had another force of, let's say, 30 Newton downwards, and all of these forces were actually trying to pull that chocolate there. So the resultant force is going to be 50 plus 70 in the upwards, and again you just minus that 70. Whatever answer that you get is the direction in which this a bar of chocolate will move. So in which direction, guys? Guys, are you there? Are you still calculating? Remember, guys,
So
in
it's
case if you've
90.
got so the first one you're saying 90 in which direction?
To the positive, 90 upwards.
Are you all getting the same thing, or do you agree with LB there? So LB, you are 100% correct. I'm not sure if the message is still delivering to others, because it does happen, guys, that I ask a question and you find that the message is still on the way. So that is why I try to say, you just mention your name and I will recognize, just in case if maybe LB's internet connection is strong and yours maybe due to load shedding is weak. So you get the message a bit later. So it is for that reason. So in this case, LB is right. She's saying, because you notice we've got a force of 70 upwards and we still have another force of 50 upwards, and then we have this one going downwards. So when you calculate the resultant force, we just want to know generally in which direction will this box move. So obviously these guys are pushing or pulling upwards with two forces, which is upwards of plus 50 plus 70, and you only have one of minus 30, and this is going to be 90, which is a positive Newton. So that means with these two pulling upwards, this one pulling downwards, this one is going to lose. But generally this thing, it's going to be moving upwards at 90 and not necessarily at 120, because also this one is cancelling some of the upward force by that magnitude. Same thing here. I'm not sure if anyone else would also like to try that one, but most importantly for this one, LB, you are right. We say 90 degrees upwards, and we don't just leave it as 90, because force is a vector quantity, therefore magnitude and direction. Anyone else to try that one? Guys, are you still there? LB, are these guys not
Yes,
watching
sir.
Gomorrah?
Yeah?
Yes, sir.
Are you sure Shreyas is not watching Gomorrah there? I'm starting to suspect. Let's
So
see.
maybe he is.
But no, Shreyas, I know he's in the lesson. Shreyas, do you want to try that one?
No, sir.
Okay, let me explain it, Shreya. So in this case, it's more like you have, can you see with the arrows, you have 30 Newton in that direction. You also have 5 Newton in that direction. So it's more like you just say force a resultant is equals to that direction. We can assume it to be negative. So it's more like you have negative 30, and then you also have negative 5. But can you see this one is in the positive direction? So you just say positive 40 there. This is equals to, you punch all of this on a calculator. I think this is
5.
35. I think you're going to have
Maybe
positive
positive
5.
5.
Yes. So can you see? It's more like this tennis ball. It is actually going to move in that direction at a magnitude of 5 Newton, or the right team is going to win, and this thing is more like it's being pulled in the right direction at 5 Newton. Does it make sense there, Shreyas?
Yes, sir.
Okay, 100%. So now, can you see, in our case, examiner is trying to be tricky there. He's not giving us obvious stuff or something is being pulled vertically upwards or horizontally to the right. But in this case, it's being pulled at an angle. So that's what makes it a little bit more tricky. So I'm just going to remove all of these that I used as an explanation and try to tackle that one and show you exactly how you solve that. So in this case, where you are dealing with forces at angles, just know that here you are now having a right angled triangle. Just know that when you have a right angled triangle, you have what we call what is it? Sine angle. It might be useful there. Let's see. Cos angle might also be useful. Tan angle, it might also be useful. And again, your theorem of Pythagoras, r squared is equals to x squared plus y squared. So these are the tools, LB, that we need to be having when we are dealing with this type of problems. So just make sure that you have all of these tools because you might need to use them. So when we talk about the resultant force, you need to firstly calculate the forces horizontal. You need to calculate the forces horizontal and again calculate the forces vertical. Once you've calculated the total forces horizontal and the total forces vertical, you can therefore use theorem of Pythagoras to calculate the resultant force or force resultant. So that means force resultant is going to be a F resultant squared. So it's more like you are calculating for R, which is going to be equals to your forces horizontal squared, which is more like x squared, plus your forces vertical squared. So can you now see that you need to strategize in terms of how you are going to tackle this question? And then from there, you can therefore use either sine, cos, or tan in order to calculate the angle. And that angle is going to represent the direction for that resultant force. So with this type of questions, guys, you will only understand fully towards the end of us solving that problem. So let me try to remove, I'm just not sure of exactly what to remove in order to answer that question. Okay, because this lesson is being recorded, I'll just remove all of this. Let me just remove all of this and try. Maybe let me just remove up to there and hope that we will have enough space. So let's see, guys. Let's maybe start with calculating the forces horizontal. So let's say forces horizontal will be equals to, let's see, we can start with the first force, guys. We know that the first force, what is hypotenuse there? Hypotenuse is 500 Newton. And then for this one, for Q, we know is 200 Newton. And then for this one, for 60, we know is 300 Newton. Remember, for you to calculate these two components, you need only two things. You need the force and the angle. That's all that you need in order for you to calculate the third component. And once you have that, you can still calculate the other component. So let's firstly have a look at this triangle and try to calculate the horizontal component. So you can see you have hypotenuse and you have angle there. So which trig ratio are we going to use in order to calculate that horizontal component? Anyone to give it a try?
Sir,
Yes, LB, go for it.
are we supposed to use cos theta.
And the reason to that,
Because it's at an angle, I guess. I forgot what you said last time.
okay, it's fine. And then anyone else to also try before I continue with that one.
Oh, because it's in the x-axis, horizontal.
Okay, as a reason. So it's fine. Let me also remind you again, LP. Let me try to redraw that triangle and say we have 500 and we have 10 degrees. What we are looking for is this being the horizontal axis. So my question was, which trig ratio are we going to use to find that side? And remember, LB, you mustn't be confused by the forces being 500 or whatever. You know very well that when you have a right angled triangle, you've got sides, namely hypotenuse, adjacent, and opposite. So according to this right angled triangle, this side, is it hypotenuse, is it opposite, is it adjacent? Whatever that it is, which trig ratio can we use there?
Wait, which side? The hypotenuse?
The force horizontal component, the horizontal force component. So that means we've got two sides, the vertical and the horizontal. So we need the horizontal force component.
So we're gonna use cos, I guess, because we have the nah, let me just leave it. I'm not sure.
Okay, no, it's fine. I'll just remind you guys. So remember, guys, I'm not sure what could be the reason why you are confused, because one thing for sure, if this was a trigonometry question, I know you were going to get it right. So I'll just make it easy for you guys. Ask yourself this question. We have, let's say, side number 1, side number 2, side number 3. Which side is which, guys? Which one is what? Which side is which?
So number 1 is the hypotenuse.
Mm-hmm.
I think number 2. Is that number 2?
So this is 2,
number
3.
2 is the adjacent.
Mm-hmm.
And then number 3 is the opposite.
You are 100% correct there, LB. So now, which trig ratio do we use to find side 3?
So are we gonna use cos?
Okay, what is cos? What is the trig ratio for cos?
Adjacent over hypotenuse.
Adjacent over hypotenuse. Okay, which side is adjacent?
Side number 2.
Side number 2, it is that one. Which side is hypotenuse?
Side number 1.
Side number 1. Which side am I saying we are looking for between 1, 2, 3?
We're looking for number 3.
So can you now see that cos fails because cos talks about side number 2 and side number 1?
I think you're going to use sine.
Why sine? Someone said sine, but why sine?
Can I answer to that?
Yes.
Because we have the hypotenuse side.
So, a response to that, Tebatsu, you say it's because we have hypotenuse and we are looking for the opposite, which is the side that I'm looking for. LB, I need to detect or diagnose the reason why this is confusing you, because if I don't work on that, you guys won't confidently answer this question. So, LB, do you understand? And when you say you do understand, what is it that made you to understand? Or does it still not make sense?
So it still doesn't make sense.
Okay, so guys, in this case, you just need to know that with this trig ratio of sine, cos, and tan, which side are you looking for? Okay, between this side and that side, which one is the vertical side and which one is the horizontal side, LB?
So the horizontal side is side number 2, then the vertical side is 3.
Mm-hmm. So that means the problem is here, not knowing which side is vertical and which side is horizontal. Let me try to check again. Shreyas, do you know between these two lines, A and B, C and D, do you know which line is vertical and which one is horizontal?
No, sir.
Okay, so now I'm able to detect exactly where the problem is. So, guys, let me say to everyone to say, always, this is vertical line. Always, always, always. This is vertical line. And then this is the horizontal line. So you just need to remember that the y-axis, it represents the vertical line, and then this x-axis, it represents the horizontal line.
Wait,
Uh,
so isn't 2
mhm.
isn't 2 the horizontal side?
No, 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 no. 2 is not the horizontal side. A line that is straight from top to bottom, it's vertical. Then from left to right or right to left, it's horizontal.
Which means that I was looking at it at the wrong angle then, because I thought that was the horizontal and that was the vertical.
No, 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 no. So always a line drawn from top to bottom is the vertical line. A line drawn from left to right or right to left is horizontal. That's why I'm saying you guys try to turn it somehow, because maybe you remember that Cartesian plane when we're doing trigonometry or something. I'm not really sure in terms of where you guys are confusing this, but just
Yeah,
make
that's
sure,
exactly
LB.
what I did.
So just make sure that a triangle can be in any possible way. But even if you don't know which one is adjacent, which one is vertical, which one is horizontal, but because I'm talking about this side, you need to know that this is opposite to that angle, this is hypotenuse, and this is adjacent. And if I'm looking for that line, doesn't matter whether it's horizontal or vertical, but because it is that side, then you know we should use sine. Why? Because it is the side that has got opposite, and again that has got hypotenuse. So just make sure, guys, that you now fully understand what is meant by the vertical and the horizontal. It doesn't matter whether the angle is there. If the angle is there, this line is the horizontal, this is the vertical. But because the angle is there, you therefore need to know what is the name of that side, this side, and that side. The easy side is always hypotenuse, and then adjacent and opposite, you just need to check where is the position of your angle. So I hope that one, guys, it's going to make perfect sense to everyone. Shrias, does it now make sense? LB, does it make sense now?
Yes, sir.
Yes, sir.
Everyone else, are we understanding it better now? We pelo li are we now on the same page?
Sir.
Sir.
Yes.
Okay, so now that means let's see, can you see P is towards the right? So that means we can assume towards that direction being positive. So these arrows, they speak, guys. Let me just bring this one to say, you can see, making reference to this line, you can see these two are in the right words or in that direction, and this one is the only one in that direction. So that means R is actually in the negative direction, and this one is in the positive, and this one is in the positive direction. I hope that makes perfect sense. So that means which force? This force is actually, when we have a look at this side that we are looking for, we say we are using what is it? Sine angle. What is the angle? Angle is 10, and we said sine is actually opposite over a what is it? It's opposite over hypotenuse. So this side LB is actually force horizontal, and then this side is force vertical. So in all
Sir.
of this, you
Wait, aren't we going to say F sine theta? Then just replace the F with the 500.
so that's where I'm heading there. But now, do you understand the force V and the force horizontal there? Do you agree with me on that one?
Yeah, so I was just confusing it. I'll just look at what we're looking for, then with the related with the trig ratio. It's fine.
Okay, so as long as we are on the same page there, so you are 100% with what you've said. But to go it step by step, you guys are saying opposite. So opposite is FH over a hypotenuse is therefore 500. So you just cross multiply, you are having a 500, let's see, sine angle of 10 degrees. This is force horizontal for that force of P. So that is why there you are going to have positive 500 sine of 10 degrees. Then you say plus, because we are going to calculate all the horizontal forces. So that means we're going to have 3 of them. Then we move to this next triangle. So according to this next triangle, what are we therefore
So the board
having?
is blurry.
Let me see. Is it still blurry? How is it now?
Yes, or maybe it's only me. I don't know.
The other guys,
But,
can you see there? It's blurry, ne?
Yes, sir.
Okay, if it is, let me try to leave. I'll come back. How is it now? Is it still the same?
no, sir, it's fine now.
Yes, sir.
Okay.
No, sir,
So
it's better now.
all right, now we are on that triangle. So let's see. We have that triangle, a 90-degree angle there, and then we have 200 there. So let's see. Do you guys agree that this is a vertical, because we said this is the vertical line and this is the horizontal line, and we have an angle of 30 degrees there. What are we calculating, guys? We're calculating the forces horizontal. So which trig ratio are we going to use there? Anyone to guess?
Wait, so I said which side are we calculating?
Okay, this should guide you in terms of which side we are calculating. So we are calculating the horizontal sides. So in all the triangles, we are calculating the horizontal sides. When we are done, we are still going to do the same but for vertical sides. So that's how you answer this question.
So we're still going to use sine.
Okay, I'll be saying sine, and then someone else.
Cos.
But why are you saying cos?
So because we're calculating for our FH.
100%. LB will still need to detect what's the issue there. So why are you saying sine LB?
I wasn't thinking, sorry.
At least you are not watching Gomorrah. So can I say you understand why cos now?
Yes.
Okay, 100. Most importantly, guys, the sine is the most important one. So you guys are correct. We are using what is it? What are we guys using? We are using cos because FH in this triangle, or according to this triangle, it is the side which is the adjacent. We know that cos angle, the angle there is 30 degrees, is equals to adjacent over hypotenuse, and then we know adjacent is FH over 200. So you cross multiply, and then this is actually, remember, positive. Why positive? Because this arrow you can see is in that side of the direction. So it's positive 200 cos of 30 degrees. Then plus, let's now have a look at that triangle. We also do the same there, guys. Let me try to redraw that triangle. So let's see. That one is like this. And then we said it forms a 90-degree angle there. And we said it's 60 there.
So it's so
and then
blurry.
we know that one. Okay, I'll just adjust it just now. Let me say force vertical and then say force horizontal. So guys, let me quickly go out and then I'll come back with my data. Let me I think now it should be better, guys. How is it, LB? Is it fine now?
Yes, sir.
Okay, 100%. So what are you guys saying there according to that right angle, the triangle there? Guys, are we still together there? Remember, in case if you've got no idea, you can just mention to say no idea so that I'm aware you got the question, but you don't know where is the starting point.
Wait, are we using sine?
Okay, LB saying sine. Someone else to give it a try. Molefe, you were breaking. I couldn't hear a thing. Can you maybe just try to say it again? What did you say? Okay, it's fine. LB, let's talk. I'm worried, guys. I'm worried. Your silence is worrying me. And one thing for sure, this type of questions, they will be there. It's going to be a bit tricky, but it's fine. LB, I want to make sure that I detect that thing that I still need to detect. I need to diagnose it and treat it. But let me give an opportunity to explain for sign. Why sign?
Wait, so I don't know what we're supposed to calculate, right? But okay, let's assume that the hypotenuse is 1 and the adjacent is 2 and then the opposite is 3, right?
Oh, okay. So let me do it. I'd say 1, 2, 3. Okay.
Wait, what are we calculating? The horizontal or what?
So I'm just not sure of how to respond to this one. But remember, okay, yeah, I think I've got a way. What were we calculating previously, or on the previous two questions? What were we calculating there?
The horizontal axis.
Yes, so we are still on the horizontal axis. So, guys, for 1, 2, 3, we'll be calculating for the horizontal. When we are done, we are going to move to the vertical. So that is where we are heading. So that means 1, 2, 3, you formulate for the horizontal. Once you are done, we'll do the vertical. So now you can go ahead, Albie.
So I thought we were okay. Now I see where I went wrong. Okay, so we are, what's this? We're given hypotenuse and we're given the adjacent, and we have to find FH, right?
Yes.
Oh, cos.
Cos. So exactly that. So can you see why I'm saying I'm worried, LB? I want to detect that thing that makes you to get opposite trig ratios. But in short, I think it will make perfect sense when I say the procedure is that we firstly find the FH. When we are done, we are coming for FV. Then once we have both, we then use this formula to just calculate the resultant force. So it's more like this is the formula for the resultant force. So that means obviously in this case is going to be 300 cos of angle. But be careful, in this case is minus. Why minus? Because you can see it's acting in that opposite direction. So that is why it's minus 300, what is it? Cos of 60 degrees. I'm not sure if that makes sense to everyone, guys. Can you guys confirm if it makes sense there?
So you say it's because it's acting downwards, right?
Let me bring this one. I'm just not sure of how to explain it. Not necessarily.
Oh yeah, I see. No,
You
I
can
see it.
see, ne? Yes. So this one, those are in that direction, but this is in the opposite direction. So you can just see by the arrow there, and then this in the. So are you all guys following there?
Yes.
Okay. So quickly, let's do the same for force V. So I hope for force V we won't struggle that much, because now you've got an idea of exactly what we're doing there. So for force V, let's see, for that one, what are we having there? You know that this is force V. So which trig ratio are we using there? Someone remember to mute your mic. maybe I need to draw that triangle. So just make sure, guys, that you are able to draw this triangle by yourself. We have that horizontal there, and we have an angle of 10 degrees there, 90 there. Which trig ratio are we using there?
Sine, sir.
Shreyas is saying sine. Another one to give it a try.
Say cos.
Maybe let's start with Shreyas. Shreyas, do you want to try and explain why sine?
So because f of v is the adjacent side, which we have to find.
You are 100% correct that FV is the adjacent side. But which trig ratio between sine, cos, and tan has got adjacent?
Cos, sir.
So between sine and cos, which one will be the correct trig ratio to use?
Cos.
So you now have an idea of how to determine which trig ratios to use, isn't it? Everyone, does it make sense now?
Yes, sir.
Yes,
100%. So that means, Shreyas, in which direction? So can you see the force vertical is actually in the upwards direction because of that arrow being in that direction. It means for the horizontal is going to be there, for that is going to be there. Also for this one, if it's in that direction, it's going to be in that direction, and again that one vertical. It doesn't matter if that line is on that side or it's on this side, you just know it's vertical. So this one is obviously going to be in that direction, and again downwards. It doesn't matter whether that line is there or is there, we just know that we have a v vertical. So that means it's going to be positive. What is the force there, Shreyas? It's 500, and then you just say cos of a 10 degrees angle. So normally, okay, let me not even say that. I will explain it at a later stage. So what about the next triangle, guys? Which trig ratio are we using there? Are you still thinking?
Yes, sir.
Okay, Onkamurets, are you still there? Molefe Buipelo, Tebaso, are you guys still there? Are we still together, guys?
Yes, sir.
Do you not want to give it a try, Onkamurets?
I'm still thinking.
Okay, so remember, guys, for you to be able to understand this, you must have gone through that a lesson for trigonometry. So I'm now noticing that I might need to do a revision on that. So LB, what you need to do while you're still thinking is to redraw that right angled triangle there. Just draw it exactly as it is. You know you've got that there, and you have 30 degrees there, then you have 200 Newton there. So ask yourself a question: which side between these two are you looking for? So let's say maybe 1, 2, and 3. Which side are we looking for, guys?
So we're looking for 3.
For side 3. Okay. What is the name of side 3?
It's the opposite.
Which trig ratio has got opposite?
Sine.
What does it mean, LB?
Means that we are using sine.
100%. So exactly that, guys. Those are the questions that you should be asking yourself to say, okay, which triangle, and not just a triangle, but a right-angled triangle. So this is it. So you have this size. Which side are you looking for? Is the vertical one, which is number 3. Which trig ratio has got that opposite? So you know its sign, which means you are going to use sign. Most importantly, the arrow, is it up or down? So because of that, in that direction, it means it's up. So that means you have positive, what is it? 200 sine of angle being 30 degrees. Then you say plus, and then you do that last triangle there. Anyone to give it a try for the last triangle there?
Give it a try.
Lee, give it a try.
We're gonna use sign for
Okay, let me
the
try to draw it. So we have 60 there, and then we have 300 there. Okay, so Lerato, go for it. Explain.
So we're looking for the vertical side, right? So yeah, on the vertical side we've got opposite,
Mm-hmm.
and having opposite. I mean the trick. Yeah, that one, it's
Trig ratio.
sign. Yeah, trig ratio is sign that has opposite. So yeah, it's opposite.
And then in terms of the sign, are we having positive or negative?
It's negative.
Okay, ladies and gentlemen, do you agree with her on that one?
No, sir. Maybe I
Okay,
might be wrong also.
okay, give it a try.
Wait, isn't number 1? Wait, no. Number 2 is the opposite, right? Number 2 is the opposite, and then number 1 is the adjacent. No, yeah, I think it's sine, sir.
So that's how you think it, LB. That's how you think about it. You ask yourself those questions to say, which side exactly am I looking for? Then you notice you're looking for side number 2. Then is this side adjacent or opposite? It's opposite. Because it's opposite, then it means you use sign. That means, as Lerato said, there is going to be negative. Then, let's see, then it becomes negative 300. Then you use sine of angle 60 degrees over there. So that's how you determine those. So something very much important that I wanted to tell you guys is that just make sure that if you start with the horizontal forces, make sure to get it correct, because after you got it correct, if you used sine there, on the vertical you use the opposite sign. If you use cos there, on the opposite you use that. On the vertical you use that. If you use cos there, here you use sine. So that means if you can make sure to get this one correctly, when you calculate for the vertical, you just do the same but with opposite signs. Does it make sense, guys?
Yes, sir.
Okay, then in that case, LB, let's now try to punch all of this on a calculator and let me know what are you guys getting there.
So for the first one, I'm
Mm-hmm.
getting 0.22.
0.22. Anyone to confirm that answer? So in the meantime, while they're still confirming, you can now punch the second one and let me know what are you getting there.
I'm getting 332,5 comma 5 comma 60 332 comma 60. Wait, you see after the comma there's 59, right? So how do you convert that? Is it gonna be 60?
Remember, you're saying after comma is 0,59, isn't it?
Yes, and then after the 9 it's a 6.
Yes, so this is what guides you in terms of how to round it off. So you are correct, it's going to be 60 there. Okay, this is what she's getting for the second one. So are you also getting the same answer, guys?
So for f of h, I'm getting 110,0291696.
So we can maybe round it off to become that. And then the second one, what are you getting?
So for the second answer, I have 301,00284.
Anyone else to confirm? LB, try to punch the first one again. There's no way it will be 0, that, because if you remember, I'm just trying to visualize by looking at these forces to say we had force of 500, we had another one of 200. So it should be in that region of maybe between 500 and 200.
Oh yeah,
and not
sir.
there.
I see.
So
I left the
even when you
bracket by
punch,
mistake.
even when you punch and you expect an answer, it should also make sense. So you should be able to notice that maybe something went wrong. But now,
yeah, it's 110,03.
okay, and then this one, is it correct? This one, guys.
Yes,
Shreya's got
sir.
a different answer. So Shreya's, just make sure that you punch it correctly there and check where you might have gone
So
wrong.
for my second answer for f of v was 301.
301 for, let me do this. For FV, Shreyas is getting 3. But which one is correct? Did someone else also get this one, or you getting 301?
Getting 332,6.
So Shreyas,
I
somewhere,
said 332,6.
you might have
330.
made a mistake. I'm not sure. Shreyas, just make sure that you don't forget that minus, and again, just make sure that as you punch all of this and you say cos, it opens a bracket, you must close it and close it again, because you close the first one for the angle and the second one for the whole of that. And then you also do the same there. When you get there, inside the brackets is negative that, and also make sure calculator it's in degrees. Okay, so in short, guys, what we have just done there, it's more like we converted this force and this force and this force into the vertical and the horizontal force. So it's more like what we have done is to say those forces acting at a certain angle, it's almost the same as just one force, which is a horizontal force, which has a magnitude of 110,03 Newton, and at the same time the same force as what is it, 302 let's say 60 Newton, being the force vertical. I'm not sure if that makes sense, guys. So it's more like all of these 1, 2, 3 forces acting at angles, we converted them into a simple single one force in that direction and a single one force in that direction. So what we now need to calculate is the resultant force. What is the resultant force? The resultant force is going to be that force in that direction, and the direction is going to be determined by an angle being that angle there. So when you calculate the resultant force, that's where you use this formula, because you have the force horizontal, you have the force vertical. It's more like you want that one being the resultant. So that means force resultant squared is actually equals to, what is the horizontal force? You guys said is 110,03. You close, you squared, plus what is the vertical one? You guys said is 332,60 squared. So what is force resultant, guys? But just make sure that it makes sense in terms of what we are doing over there. What are you guys getting?
Um, 122729,36.
122.9,36 Newton. What else are you guys getting?
No, say 122729,36.
So this is FR, isn't it? So
Yes.
are you guys also getting the same thing?
Yes, sir.
Okay, but remember, LB, what you're calculating is FR, so you need to introduce a square root to remove that squared over there. So remember, when you use a theorem of Pythagoras, you can punch both of these, but in the end you must square root both sides so that you remove that squared. You remember, Mus?
Yeah, so it's giving me 350,33.
350,33. So this is the resultant force. It'll be 350,33 Newton. So this is the resultant force. In terms of the direction, this is where you use tan. You used sine and cos to determine the vertical and the horizontal. This is now where you use tan to determine the angle. So you just say tan of angle is equals to which side between this and this is the opposite and which one is adjacent. So remember, guys, the moment I've asked that question, what you need to quickly do is to draw that triangle. You have angle theta there. So you have this being 3, 3, 2. This is 332,60 Newton. And this is the horizontal. Remember, this is your V vertical, and this is F horizontal being equals to 110,03 Newton. So which side is opposite and which side is adjacent?
Number 3 is opposite. Side 3 is opposite.
So that means you are having opposite over adjacent. So it's 332,60 over 110,03. Then what you do, LB, is to find the second function of tan all of this. Then whatever that you're going to get is your angle in degrees. What is that? What are you guys getting there?
71,694,86546.
Let's round it off, Shreyas. What is it?
71,70.
70.
Okay, 71,71 degrees. So this is how you score yourself full marks, guys. This question, it was actually easy, but it needs you guys to practice a little bit more. So let's see, it's 71 comma that. Then when you give your answer, finally you're going to say the resultant force is equals to, what is it? What is that? It's 350,33 Newton in the direction 71,70 degrees along the x-axis, or you just indicate that is the angle measured from the x-axis. So in short, it's more like you're saying the resultant force is actually measured from the x-axis to be 71,70, and the force is 350,33 Newton. So this is the end of it, guys. I think let me quickly try to give you a problem that you can use as a practice. And if you want to check if you have done it correctly, then what I'm going to do, I will go through your calculations and just check if you've got it correctly. So would you say you understood what we've done up to this point, or otherwise do you think you need to practice more on this type of questions? What's your feedback, guys?
I'd say to practice more, so
It's a bit
because
tricky.
because not all the questions are the same. Yeah.
Yes, not all the questions are the same. You're right. And again, they might bring it in a different situation. But maybe for the sake of practice, let's say maybe we have one in that direction, and they say the angle there, let's say, is 35 degrees, and it's in that direction. Let's say maybe is 250 Newton, and this is E, and then let's also have another one in that direction, and there we've got that angle there, let's say being 40 degrees, and this is maybe, let's say, B, and then the force there, let's say it's 150 Newton, and then again maybe let's have this one in that direction and say this is 300 Newton and call it maybe D, and the angle measured there, let's say, is measured about that, and then we can say maybe is 25 degrees there. Then I'll leave it there and say calculate the resultant force. I'm not sure if you guys have an idea of where is the starting point, the resultant force and direction. So I'll just explain to you. If you have a question, you'll ask, and then we'll close our lesson. So in short, guys, you just need to be aware that we've got the X and the Y axis. So these are the tools that you're going to need. You are going to need sine angle. Let's see, you're going to need sine angle, you're going to need cos angle, you're going to need tan angle. And most importantly, we know the formula for the resultant force in this case is force R squared being equals to forces horizontal plus forces vertical squared. So 1, 2, 3, 4 is the tools that you will need. So remember, you firstly need to calculate the forces horizontal, and then secondly calculate the forces vertical. From there, once you've calculated those, you use this formula to calculate the resultant force, and then you use tan or sine or cos, depending on whatever information you have, in order to calculate the angle. So A, B, C, D, E can start with B, A, B, C, then come to D, and then the last one being D. Just follow alphabetical order. You look at this this triangle. So you can see you have hypotenuse, you have angle. This angle is measured along that x-axis. Then that's where you have your right angle decrease. Then from there you ask yourself which side between the horizontal and the vertical, which one is which. Then you know which trig ratio to use. For D, you also do the same. You have that as the hypotenuse, you have the angle formed about that. That means this is your right angle triangle there. Then you ask yourself, is this FH or FV, and is this FH or FV? Which one is which, and which trig ratio to use? Then you come to that one, you say, okay, there is the force, but the angle is there and is formed about that line. So that means my 90-degree angle is actually there. Then this side is it FV or HFH? This one is FV or FH. Then you know which trig ratio to use for calculating the FH and secondly the FV. Once you've done calculating those, you know that you use this formula. But most importantly, make sure to get the first row correct. And then once you get it correct, when you calculate FV, just use opposite signs. So it's normally between sine and cos that you need to choose from, and tan you use it towards the last step to calculate the angle. And most importantly, the arrows are going to tell whether when you substitute it's a minus or it's a negative. And most importantly, in terms of the arrows, you can say along this line, all in this direction is positive. Along this line, all in this direction, those are the negative. So, guys, did it make sense in summary, all that I've just explained? Do you think you can use this as practice?
Wait, so you said we use the Pythagoras when?
So, okay, let's maybe interpret this formula. What is FR?
The resultant force.
And then FH? Okay.
Horizontal.
FV?
Vertical.
Yeah, so here is the question. Sorry, guys. So here is the question. What is the question saying?
Resultant force and direction.
Resultant force and direction. So do you now notice when are you going to use this formula? Not yet.
When you're calculating the resultant force.
Yeah, so that means you use this formula when you calculate the resultant force, and that's after you've calculated FH and FV using the sine and cos on this diagram. And then you use tan for calculating the angle, and then you use this for calculating the resultant force. Does it make sense now?
Oh, so after adding all the horizontal components and the vertical components, then we just substitute
there. Yes.
Then from there we use the tan angle, right? Okay, yeah, I see now.
So can you all understand? Do you now all have an idea of what you're supposed to do there? Guys, Lerato Molefe,
Yes.
Shreya Stepazo Wipilo, Onkamuhes, do you have an idea of what you're supposed to do there?
Yes, sir.
Yes.
Okay, so thanks, guys. So there's no deadline for this one. Don't do it in case if you've got too much of schoolwork. And remember, guys, just in case if you've got too much of schoolwork, homeworks, and whatever, you can just miss the lesson, but just make sure to catch up. Who's coughing there? Is it difficult that it even makes you to cough? Let's see. Who was it? Was it you, Shreyas? It's fine. But remember, guys, so I think LB, you are in grade 11. Make sure to do this one. I'm going to make a follow-up on you. Shreyas, I think this one, it was exposure for you. I'm not sure if it's there in grade 10, but all of you guys in grade 11 and 12, try to work it out, because it is going to help you to understand some of the chapters that we'll be dealing with. Probably tomorrow we might be doing something else on physics, of which it will be for grade 11s and 12. I think those objects on an incline, but it's fine. Thanks for joining, guys. I'll see you on our next lesson, probably tomorrow or day after tomorrow. Okay, cheers, guys.
Thank you, sir.
Bye, sir.
Yes, sir.
Bye.